All right, pre-calc, Unit 4, Lesson 2. This is on trig functions within the unit circle. So just a quick review for like the unit circle, okay? So how I kind of remember it or how I can picture it, okay? So if we have our circle and we know that our circle is split up into quadrants. So you know that x is 1, y is 0 here, x is 0, y is 1 here. And so I always kind of remember it as saying, okay, this is going to be positive, positive. My x's and my y's are positive. Here my x's are negative, but my y's are positive. Down here in quadrant 3, my x's and my y's are negative. And here my x's are positive, my y's are negative. So I usually start just kind of labeling these points like this. And then I just really focus in quadrant 1, the first quadrant. So I know that, hey, the halfway point, the one that splits it in half, that's going to be square root of 2 over 2, square root 2 over 2. And that's going to be, again, if this is 0 degrees, this is 90 degrees. That makes this 45 degrees. And then we also have to think about, okay, how many radians is that? So I think about it as this is 0 radians, and then this is pi over 4 radians. And then this would be 2 pi over 4, but 2 over 4 gets reduced to 1 over 2, so 1 pi radians or 1 pi over 2 radians. And then we know that, okay, I also have, so at 45 degrees, I also have these degrees at 30 and then at 60. So if I think about 30, I know that I have two choices. I have the square root of 3 over 2 and 1/2. And I know that in this triangle right here, the 30-degree triangle, my x is longer. I'm going further out than my y. So I know that this is going to be the square root 3 over 2 because that's greater than 1/2. 1/2 is not as much. Whereas when I look at this triangle, if I were to say, hey, I'm rising more than I'm running, okay, I'm moving vertical more than I am horizontal. So this is going to be, the x is going to be the smaller value and the y is going to be the larger value. And so again, this would be pi over 6. This would be like 2 pi over 6, but 2 over 6 gets reduced to 1 pi over 3. So I usually just look at one quadrant and then I'm able to kind of work from there. So as we look at here, okay, we've got these different trig functions. You'll notice that they are reciprocals of each other. So sine is going to be reciprocals with cosine. Secant is with cosecant. And tangent is with cotangent. And so again, you can see it gets flipped on top of each other. And that's how we get sine is equal to y. Cosine is, or cosecant is 1 over y. Cosine of t is equal to x. Secant is 1 over x. So let's do an example. Let's say, okay, we want to find all 6 trig functions from t equals pi over 6. So all 6 trig functions. So I'm just going to kind of list them. Sine, cosine, tangent, cosecant, secant, cotangent. Now, pi over 6, I actually have that one drawn up. So again, that's nice. I can see, all right, for pi over 6, my x is square root of 3 over 2. My y is 1/2. So the sine of pi over 6, again, if I look here, sine is the y value, and I know that pi over 6 is square root 3 over 2, 1/2. So my y is going to just be 1/2 here. Cosine of pi over 6, okay, that's my x value. So cosine is square root 3 over 2. Tangent of pi over 6 is x divided by, or y over x. So again, if I just write it, that's 1 over 2 divided by square root 3 over 2. When we divide fractions, we multiply by the reciprocal. So I'm going to keep, change, flip. Now, you'll notice this cancels out. Problem is we have a square root sign on the denominator. We don't like that. So we're going to multiply both sides by the square root of 3 so that we get square root 3 over 3 as our answer. Okay? We can't leave a square root sign on the bottom. Now, if we've got this work, some of this will be quick because, again, all I have to do is flip it. So if my sine of pi over 6 is 1/2, well, this is going to be 2 over 1, which is just 2. Secant, I'm close, something very similar, but when I flip this, again, I get left with that square root sign on the denominator. So I'm going to multiply both sides by the square root of 3 and the square root of 3. So I'm going to be left with 2 square root 3 all over 3. And then cotangent pi over 6, again, when you flip it, you get 3 over square root of 3. Do the same exact thing, multiply by square root 3 over 3, but this time they're going to kind of cancel out. And so we're going to be left with just the square root of 3. So I was able to use what I know to find all of the 6 trig functions. If it was in a different part of my circle, again, I could keep the pattern going. I could say, okay, if it was not pi over 6, but it was 5 pi over 6 or 5 pi over 4, I could find that, okay? I could use what I know on my unit circle to solve that. All right, so we're going to talk about the domain and period of sine and cosine. So again, your domain is kind of like your x values, and that's going to be all real numbers. That's going to be true for sine and cosine, but range is a little bit different. Range is actually going to kind of fluctuate between -1 for sine and 1, or -1 and cosine and +1. So if we look at Desmos, so I have the sine graphed here. Again, I can see that, hey, it's going forever. Left and right, I don't have any holes in it. There's no gaps. However, it's fluctuating from this +1 to -1. And if we were to turn this one off and put cosine on, you can see that they're similar. They look very similar, but they kind of have different starting points. So they're a little bit off, okay? They're a little bit off. And when we think about how the unit circle works, so again, how, like, I have an x coordinate, if I have my circle right here, okay? This is 1, 0. This is -1, 0. Right here, this is a terrible drawing, but right here, this would be x is 0, y is 1. Here is x is 0, y is -1. So if we think about this fluctuating graph, I'm going, in terms of my y values, I'm going up, I'm going down. My y values are going down, I'm going up. That's exactly how we get this on our graph, is we say, okay, my y values, they're going up. Now my y values are going down. They're going up, they're going down. And so when it repeats like this, now if we think about a circle, and again, if we added more information, this is 0, this is pi over 2, This is 1 pi. This is 3 pi over 2. And then when we get all the way back, it's 2 pi. So we know that it's 2 pi like radians to get all the way around our circle. So these two graphs have a period, and the period is how long does it take to repeat. For sine and cosine is 2 pi. So period for sine and cosine is 2 pi. So I can go around 2 pi, 2 pi, 2 pi, 2 pi, 2 pi. I can keep spinning around. Eventually, I'm going to, if I have 7.5 rotations, after I do 7 rotations of 2 pi, I will eventually have my final answer where I can break it down into, say, 3 pi over 6 or pi over 4, and I can use my sines and cosines to figure it out. So if I want to evaluate sine of 13 pi over 6 and using its period, I'm going to say, okay, how many times can I say that 2 pi went into it? Let's subtract 2 pi. So if I try to take out 2 pi, I need to think how many times is this number going to go into my equation. What I'm going to do is I'm going to say, all right, 13 pi over 6 is the same thing as saying 2 pi plus pi over 6. And again, 2 pi could be the same thing as 6 over 6. That'd be 1 pi. So you're like saying 12 over 6 pi plus 1 over pi over 6 equals 13 over 6. So I'm going to write this as the sine of 2 pi plus pi over 6, and I want to figure out what that's going to equal. Now, again, if I think about this, what is sine at 2 pi? Well, sine is my y-coordinate, which is 0. So really, if this is going to equal 2 pi is going to equal 0, I'm really only need to look at sine of pi over 6, which, again, if I looked at my unit circle, pi over 6 had a y coordinate of 1/2, which is going to give me my answer. Last thing that we want to talk about is even and odd functions. So again, add this to your notes right here, where if you see, okay, 4 of the functions are going to be considered odd, which is sine, tangent, cosecant, and cotangent. But cosine and secant are even, which means, again, they have the same, their end behavior is the same on both sides. So again, how can you test this? You can plug in, change it negative, and if it comes out different, it is, if you change the negative inside the parentheses and it comes out as a positive, that's even. If you change it on the inside and it comes out, the whole answer is also negative or opposite, then you need to, then that function is odd. So again, you may have to identify what these functions are.